Let's solve another problem today. I have again taken this problem from E Irodov's problems in general physics. Let me quickly explain what is the problem. So here we have a small mass m which is resting on a horizontal frictionless surface. Then at time t equal to 0, a time dependent force F equal to at is applied on this mass m. Of course this force will cause this body to move. So we are required to find out the velocity of the body at the moment of its breaking of the plane, and secondly the distance traversed by the body up to this point. So let's quickly find out what are the forces that are acting on this body. So at any moment t we have the weight which is mg acting on this mass m. Then we have the normal reaction which I have represented by n, when at time t equal to t0 this n equal to mg. So since the force F equal to at is applied at an angle alpha, you will have a horizontal component as well as a vertical component of this force. So the horizontal component of this force is F cos alpha and the vertical component is F sin alpha. So now we know what all the forces which are acting on this body, and with our earlier understanding of the laws of motion and then other equations, let's solve this problem. So since the force is a time dependent force, the velocity and the displacement will also be a time dependent. So let's find out first what will be the velocity, horizontal velocity in terms of time t. So since let's consider the horizontal forces. The only horizontal force is F cos alpha. So we can write m dv dt is equal to F cos alpha, and substituting the value of F as at, we have v equal to a cos alpha t square by 2m. So we got the velocity in terms of t. Similarly, if we can find out the distance traversed s in terms of t, if we solve this equation, that is v we can replace by ds dt, and we have this. So solving this we get. So here we can have found out both v and s in terms of t. Now we have to find out the time t when the body breaks off from this horizontal surface. So what are the vertical forces acting on the body? That is the F sin alpha, n and mg. So when the body will break off from this plane, at that moment F sin alpha will be equal to mg, and of course at that moment n will be equal to 0 because there will be no contact with the horizontal surface. So let's assume that after t0 second the mass m lifts off from this horizontal plane. So at that instant we will have F sin alpha equal to mg, because at that moment the vertical force will be just balancing its weight. So at that moment we can find out what is the value of time, that is t0, from this equation, and we know t0 equal to mg by a sin alpha. So if you look at this equation, the earlier I had written F sin alpha plus n because this was the normal reaction, those two had, but n will be equal to 0 because the moment it lifts off from the surface it doesn't have any contact. Now if we substitute the value of t0 in our earlier equation of v and s, we get the value of velocity and the distance traversed by the body till it breaks off from the horizontal plane. Hope you have understood and enjoyed solving this problem. If you have any questions, please feel free to write to me. Thank you.